Okay, Happy New Year everyone. We're in 2026 and it just so happened on January the 1st I got 100 subscribers to the channel. So I decided to make a little fireworks display on screen. Might as well make a tutorial out of it. So let's start off the new year with a fireworks tutorial. So what we're going to do is we're going to create a fireworks explosion in Godot 4.4. That's what we're using now. Using nothing but CPUParticles2D. There's one thing though, I imported a little circle that I created on Inkscape. It's a small white circle. I'll put a link in the description where you can download this for your project if you want to use it. Now there's a reason I chose CPUParticles2D. We can also use GPUParticles2D. It only runs on Forward Plus and mobile. But remember, when I'm porting to my phone, compatibility works better than the mobile in my case. So I chose to use the CPUParticles2D instead because it's compatible with all these modes on the top right hand corner here. And as usual, this is going to be a 2D project. So I'm starting off with a node 2D, and let's just name this main or something because this is going to be our main project. Let's enter this and save. I'm just leaving everything disorganized in the file system. You can organize it as you see fit. And let's add another 2D scene. And we're going to make it into another node, and we're going to look up CPU because this is going to be our main node for the fireworks, the CPUParticles2D, and we'll just import it into our main scene when we're ready. Let's create CPUParticles2D, and we can leave it as is, or we can rename it fireworks. I'm going to leave it as CPUParticles2D because it's a descriptive name and it'll be helpful in this tutorial. And I'm just going to set up this project so it can show well in a mobile phone in portrait mode. So I'm just going to go into display window, and I'm going to change my viewport width, so the recommended viewport width, which is 1080, and the height 1920. We're going to leave it as windowed. Let's go down a bit. Let's change the mode to viewport so that it fits on almost every screen. Go down to where it says handheld orientation and select portrait. Let's save this now. Okay, so let's begin. Let's select the CPUParticles2D so we can see the inspector open up here. And let's start off by raising the amount of the effect. Let's zoom in to where the effect will take place. As you can see, if you look here, you'll see little dots coming down. That's the default emission that we're getting there. You can turn it on or off. We're going to leave it as emitting so we can see what is going on for now. And let's change the amount to a higher amount. Should be good. Let's start off with 100 maybe. As you notice, it's shooting down alone, so we'll have to fix that eventually. Personally, these little dots don't show very well on the screen, so where the texture parameter is here, I'm going to use a small white circle. You don't have to, but it makes visualizing the fireworks effect better and easier. Let's go into time. On the time parameters, we have these different little parameters here. I'm just going to raise the lifetime to 2 seconds. You can adjust it as you see fit, whatever works for you. Eventually we're going to use one shot, but I'm going to leave that for after we're done with the whole fireworks, because I want to see what's going on while we're doing these tweakings. And I want this looking like fireworks, so I'm going to add some sort of explosiveness. In our case, I want one explosive, so there's a burst. And if you notice here, it's moving very slowly, so let's raise the scale to 2 maybe, the speed scale. And right now it's kind of hard to see any explosive effect, so I'm going to leave the timeline alone for a bit. Let's go down to the emission shape, make sure it's set at point, and that's fine. And let's go down and go into gravity, because I believe gravity is pulling the points down, and let's set gravity to 0, so everything is actually around this area here. And we're going to need to give it some initial velocity. Let's give it an initial velocity, let's say about 50, and we're starting to see something playing off here, and maybe 150 for the max velocity. So there's a disparity in the velocity, and that looks much better now. Let's go back up to direction, and as you can see, the direction is on the x-axis in this direction. That doesn't matter because we want a circular emission. This, if we drop the spread to 0, you'll see it's just going to shoot along the x-axis. Any angle that we add to the spread here is going to go to the top or the bottom of the x-axis. It's to the basically to the left or the right of the angle of the x-axis. So if we add 45, you're going to get 45 degrees above and 45 degrees below. That's because our direction is on the x-axis. If it was the y-axis, it's going to be to the left or the right. If we add 90 here, it's going to be 90 above, 90 below, giving it 180. If we want a circular emission, let's just make this into 180. And there we go. We're getting a circular emission. This is starting to look good. Let's just add a tad bit of gravity, because when we see fireworks, it usually starts to drop after it explodes. Let's try 40. Great, I'm getting that sort of drop-in effect. That's perfect for me. If we notice now, the lifetime is exact for all the particles that are coming out. So we want some sort of randomness. Let's go down to your lifetime randomness. This will give each point a different lifetime. If we just change the lifetime randomness to 1, let's send it up all the way, you'll see the lifetime of each particle is randomized now. Some lives for a shorter period, and some particles live longer than 2 seconds. Nice, it's starting to shape up now. Let's go down, and the points all look exactly the same size. So what I want to do is I want to change the scale. So I'm going to click scale, and the scale amount, let's just widen this a bit so we can see better. So scale amount minimum, let's drop that to maybe 0.25, and let's leave the max at 1. So we have a disparity in the scale. Each particle has emitted somewhere between quarter to the full size of the particle, and as you can see here, we have in different sizes here. If you don't like how much emissions we have in here, you can raise the amount to something more if you like, 1000 maybe. I think it's a bit too much. I'm gonna leave it at 250 maybe. That looks good. The explosive force is a little too inorganic. It's just going outwards. So I think I want to dampen it a bit, because when we look at fireworks, it seems to slow down a bit at some point after the explosion. So let's go down to where we see damping, and let's add a little dampen effect. Let's try 10. It seems to be helping a bit. Let's raise it a bit more. Let's try 40. Oh, that looks good. And let's give it some disparity in the damping. So let's give it a higher max. So some particles will slow down faster than others. So now it's giving it an organic sort of look. And this is looking really good. So now basically our fireworks is ready. Let's go into main, and we can link the fireworks, and let's just move this somewhere where we can see it. So that's basically how it's going to look, and I think that's looking pretty good. We just need to add some colors and so on, but for more or less our fireworks is done. We just have to write script to spawn fireworks all over the screen at some interval, and to change the color. What we can do to get a more natural look, let's go into the CPU particles again, and we can go into color. Now you can change color directly, but it's going to have the same color right through, which doesn't look very natural. So let's just reset this. If we notice here, as I scroll in, the firework particles are not fading out nicely. So what we're going to do, rather than use a set color, we're going to use a color ramp, which will change during the lifetime of the particles. And let's delete this black point here and add a new one, and somewhere in the center maybe we can add another one. What I'm going to do, I'm going to modulate the colors after this, but I want during an explosion for the fireworks, the initial explosion gives you a bright color, maybe bright white or very bright. As it starts to burn out, it starts to get darker, so let's make the second one, let's make this into a sort of gray color, and this last one, let's delete it so that's all gray now, and let's add another one just by clicking there. And this last one, it's supposed to fade out, so let's just drop the alpha all the way down. So basically this is the effect you're going to get here. If we add a color to this, let's click out somewhere and let's go into the canvas item at the bottom here, and let's add under visibility, let's add a modulate. Let's just give it a yellow maybe. And this is basically how it's going to look. The colors seem a little off. Maybe I should drag this down a bit, and maybe my dark gray is a little too dark. Let's go a little higher. That seems a little better. Let's try another modulate color. Let's try green maybe. Try to use brighter colors because it's going to mix with the color ramp that we just made. It seems a little cartoony, but it just might work. So this is the, let's save this. So this is the basic setup we're going to use for a single firework. What we're going to do is every time we spawn a firework, we're going to start the CPUParticles2D and use code or script to change the color each time. So now if we go back to the main, and let's actually run this and select as current. There we go. It looks nice. You just have to write code for fireworks. So what I'm going to do now, I'm just going to go back into the CPUParticles2D. I'm going to add a script to it, and let's create a script. And in the script, I'm going to delete process. I'm not going to use process. You can use ready. I'm going to use ready. And at the top here, I just want to add an export area so we can see it in the inspector. There we go. And let's create a variable for an array of colors. Remember I said we want to use brighter colors, so don't forget that. If you use dark colors, it's not going to look like fireworks very much. I'm going to call it color mod array, something descriptive, and make that as a type of array. Of type color. And what I'm going to do here, I'm just going to set the modulate to some color just to test. Let's say color dot red maybe, and let's just test this and see if it works. Great. And if we change it to another color, let's say blue, let's save that and see if it works. Great, so that works. So every time we instantiate our CPUParticles2D, it's going to use the modulate that is in the ready function. So what we can do now is write a function to choose a random color from the color mod array that we created up here. We can see color mod array here, and let's just click color mod array in the inspector, and let's give it a few colors, maybe 4 colors, and enter, and choose our colors here. As I said, bright colors, so let's make the first one probably a bright green. This should be okay. Let's do the second one, maybe a light blue or bright blue, something like this. Should be nice. Let's do this as yellow, so let's drop the blue a bit, see if we can get yellow. Let's click yellow here, a bright yellow, that should be good. And something else, maybe purple. Let's see, there we go, pinkish color, maybe a bright pink color. Here it seems a little dark, but we can still use it anyway. And let's save that, and let's write the code to get random colors. Now, somewhere back when I started making videos, I had code for random colors, so you can always go back and check how to do random colors. I'm just going to create a function called random color. You can name it whatever you like, and it's going to return a color for us. So let's return a color, colon, and here I want to get like the size of the array in case we add more colors. So let's create an internal variable called maybe array size, and that is going to be equal to the color array, color mod array dot size. So that's going to give you the size of the color array. Of course, the function is in red because it's not returning anything as yet, but we'll deal with that in a bit. From this array size variable, we're going to get a random index because we're going to use that index to apply to our array to get a random color. So let's get a random index. Let's just name this random index, and we're going to use randi, random integer method. Remember, random integer method goes from 0 to whatever value you put minus 1. In our case, it will be our array size. So that's going to give from 0 to, in this particular case, we have 4 colors. So it will be array size, which will be 4 minus 1. So it's going to go from 0 to 3, which is exactly what we like according to the color mod array on this side. It's exactly what we want to get here. We're going to use this to get our random color. Let's just call it R color or rand color or whatever. But if you use rand color, it's going to be the same name as the function, so we don't want it to clash. For our rand color, it's going to be equal to color, and that color is going to be a random color that you just created using the random color function. So to get an actual color, we're going to have to use the color mod array and pass into it the random index that we just found, and that's it. We just need to return this now. Return, and we're going to return that random color that we just created from our array. We're just going to plug this into where we modulated up here, and where we said modulate, we're just going to add that random color. So this rand color, and there are no errors. Let's save this and just run the project a few times and see if the color changes. It's blue. Let's try it again. It's green. It's yellow now. And that's the kind of effect we wanted. So we just need to write code to spawn our fireworks all over the main screen. Let's save this. Before we move on, I just want to correct this error here, this warning. Root node of a scene is recommended to not be transformed. So let's go into the transform of the CPU particle and see what happens here. For some reason it was moved, probably by mistake. So let's just reset that and save, and the error is gone. We can go back to main now, make sure it's still working. It's working great. So we got this working now, but we don't want the same fireworks to be emitting all the time. So let's just make this one shot. If you notice, emitting is going to come off automatically. Let's save this, and you notice we're not seeing anything on the top here. That's because in the code now we don't have any emitting. In the code we want to run the CPU particles code, we want to run emitting. So let's just type in emitting. If we hover over the name emitting here, we'll see use emitting and call it as true. So it's going to shoot an emission once, save, and then it's going to be a one shot, so it's going to stop after that. And there we go, we have one emission. You can try it again, different color, so it works. So what we want to do now is we want to write code in our main scene. Let's just remove CPUParticles2D from the hierarchy here, and we're just going to add a code to this. Let's click add script, and we're going to add some script here so we can spawn fireworks as we need. So let's just add a little space. Let's create our variable. Let's create a new variable to preload the fireworks scene. So let's just call it fireworks scene, and that's going to be a packed scene, of course. And we're going to preload this, and it's going to be our particle2D scene, the TSCN. We want to get some sort of random position within the viewport within our screen. So let's just create a variable called view size maybe, and that's vector2. Let's add a ready function, and in this ready function we want to get our view size. That will be equal to, we're going to get a viewport, not the viewport rect, the viewport, and we're going to get the visible rect, which is a cleaner way of getting our viewport, and from that we're going to get the size. So this is going to give us the size of the viewport depending on whichever device we're using. And let's go below that and create our spawn fireworks function. Let's create a variable in here for our fireworks, and that's going to be equal to our fireworks scene being instantiated. And of course we have to add this to the scene. If you remember from some of our other tutorials, we have to add our firework. And in our ready function we can just test it by calling our spawn fireworks. Let's save this and let's just run this, and there we go. Of course it spawns at the top left hand corner because we didn't give it any positions. Let's add a function to find or create a random position. Let's call it rand position, and that's going to return vector2. Let's create x position variable, and remember vector2 values are floats, so we're going to use randf. Of course randf, as you can see here from the pop-up, it gives you a random value between 0 and 1. So we're going to take that random value between 0 and 1 and multiply it to the viewport x, and we're going to do the same thing for the y value. Y pos is equal to rand f multiplied by our view size y value, and from that we can get our let's return our vector2 value that we're going to use for the position using our x position and our y position that we just found. And of course I forgot to put the open and close brackets here. Below the instantiate, before we add a child, we just want to get the fireworks and add its position dot position will be equal to our random position, and that should work fine. Let's just run this. There's a random position there, and now let's just add something to instantiate the fireworks over and over. So let's just add a child node and add a timer, and let's click timer and go into node, double click timeout, connect this to our main script. There it is at the bottom, and every time the timer times out, we want to spawn fireworks. If you like, we can remove the spawn fireworks from the ready function, but I'm going to leave it as is. And let's just go back in the inspector for timer and configure timer. We're going to make this an auto start. Let's save and let's run this and see what happens. And there we go. This is the exact effect we wanted. 1 second wait time seems to be alright. We can cut it down a bit to make it a bit more dynamic. Let's use 0.5 and see how that looks. Save. This is much better. Of course, you can play around with the colors and the gradient stops that we have, and darken it a bit more, lighten it a bit more to get better effects, better colors. But this is just a quick way to get fireworks on your screen. Okay, let's look at something here. When we start the fireworks, you'll notice that I raised the timer to 0.1 so we get more fireworks on the screen at one time. But if we go into remote here and look, we'll see that we get a perpetual amount of fireworks on the screen, and we keep getting more, and it's not stopping. So we have to find a way to delete these and get rid of them automatically. Let's stop this. What we can do is we can go into CPUParticles script and just add a simple line here that will detect when it's finished. Let's type finished, and we're gonna connect queue free. So what we're saying here is when the CPUParticles2D that the script is attached to in this scene here, when that is done, we're going to connect a signal that will free the queue, or in other words, delete or destroy that scene. Let's try this. Let's save and try it and see what happens. Let's switch scenes. That's working in the background. We're going to the main scene. Let's go into remote. And if you notice here now, we have a certain amount of CPU particles, but it's not going beyond that. And of course, you can use the same setup, and you can use it for explosions. You can use it for confetti if you use a different type of sprite. You can use it for magic bursts. You can use it for level up effects. All these sort of things you can use CPUParticles2D for, or even GPUParticles2D. So I hope this was helpful, and see you in the next one.